All right, hi, my 130s. We meet again. So it is week 13. We're actually getting into chapter 7 a little bit early. We should be done with chapter 7 material in terms of recordings by the end of this week. Basically, you can use this. This is a guide. Remember, it's on Canvas under Files and Review. I think it's Homework Examples. Review Homework Examples. One of those. I'll double check and get back to you on that. But you can go to Canvas Files and then you'll find these documents. So basically today I'll go through 1 through 5, Tuesday 6 through 10 with PCC group, Wednesday 11 through 15 with LAC group, and then Thursday 16 through 20 with PCC group. And then we'll be done with the new chapter 7 material, which takes us into chapter 8 and 9 early. And then we'll have more time closer to the end of the semester to review. All right, let me go ahead and clear all this out. And then I'm going to maximize this and hope that I don't have too many problems maneuvering this sucker today. All right. So just to give you some insight, a little bit more here. This is the assignment that we're going to be working on. It's very similar to your homework, so it'll help you through it. I'm going to start with question 1. So question 1, you're to solve u squared equals 64, where u is a real number. For this, before I get into the meat of this problem, I want to give you a little bit of note here. Chapter 7 is solving quadratic equations and expressions. So we're looking at expressions. Let me make this a different color. Expressions of the form ax squared plus bx plus c when expanded. And the equation part, you want to be able to solve when this is equal to 0. Okay, so we have learned a few methods so far to solve quadratic equations. So let's just kind of review those methods first, not in a bunch of detail, but just so that we're on the same page. So we looked at factoring, and those are just for special factorable quadratics. We'll find that not all quadratics are factorable. We've also looked at the square root property. Which is similar to question 1 up top. And essentially, you might not remember it by name, but for those ones, you have some kind of format. Ax squared plus c equals 0. So notably, your b value in this case is equal to 0. So we've actually looked at these. We've also looked at square root property without the name when we use Pythagorean theorem to find a missing side of your triangle. So the ones we still have to cover, we're going to cover completing the square. And then from there comes the quadratic formula. I would really love to go into the details of how completing the square works out into quadratic formula, but I don't really have the time right now in terms of the actual lecture portion. If you're interested in seeing it, let me know and I can make a video for you, or at least find one for you. I do want to mention that the quadratic formula solves, I'll call this equation star up here. So even if b is equal to 0, and you could use square root property, you wouldn't need to. Quadratic formula solves all quadratics. Okay, so any quadratic can be solved with quadratic formula. Now, if you need to, go ahead and take a picture of this. I'm going to erase a few of these details and then add the quadratic formula here. As a matter of fact, what I might do instead, let's see if this works smoothly at all. I'm going to just take this whole piece and move it upward.
There you go.
So I know you'll have some trouble seeing some of the stuff that's up here, but that's fine because I went through that. I actually want to write in what the quadratic formula is. So if you're trying to solve this particular formula star, your solutions.
Professor,
Yes.
for the AX squared, is it always going to be squared, or can it be to the power of like 3 or something else?
Always squared. It's a max of square if it's quadratic.
Okay, thank you.
Mm-hmm.
Is that already a quadratic equation? Because why am I thinking 4? Why is that quadratic? Because of the order, maybe?
It's quadratic because 2 is the maximum degree. It's the maximum exponent on your x terms.
Okay, thank you.
So it's a quadratic in x. Okay. Are any other questions before I continue? Okay, good. All right, so basically your solutions to this particular equation up here, it comes from completing the square. But you're going to get negative b plus minus square root b squared minus 2ac divided by 2a. Okay.
Mm-hmm.
And then I know I'm going to throw a lot of details at you right now, but there's going to be one more detail I'm going to throw at you. And that's going to be the discriminant of your quadratic. And the discriminant comes from the part underneath the radical sign from quadratic formula. It's b squared minus, oh, my bad, hold up. I caught my mistake. Let me redo this part. Sorry about that. How could I forget? I've known this for years. Okay. So negative b plus minus square root b squared minus 4ac divided by 2a. And the discriminant is still the part underneath the radical sign. It's the b squared minus 4ac. We're going to be learning some details about the discriminant within our problems that we cover. So I just wanted to make sure that we have all this down first. Go ahead and take a picture of that if you need it. And then because there were some questions that have popped up, I'm going to go ahead and pause the recording and take a few.
Turn on that light.
All right, guys, so we went over the methods for solving quadratics in the last little bit that we've done here. I do want to emphasize, because it has seemed to be a common concern. Remember, for quadratics, and we'll just make them quadratic equations just so it'll be a little bit easier. So the expression part would be ax squared plus bx plus c. Any quadratic can be written in this form. Now the part that makes the equation the equal 0 part. So just emphasizing that what makes this a quadratic equation is this power of 2 right here. Okay, so if you had a power of 3, that would be what's called a cubic equation, and so on and so forth. So, all right, so for the first question, We're solving u squared equals 64, where u is a real number. Simplify your answer as much as possible. So I just want to emphasize here that this equation that you see right here can be written in a quadratic form. If I subtract 64 from both sides, I have u squared minus 64 equals 0. Okay. Now, just something I want you to recall before we actually get into the solving of this problem. Recall, this is actually a factorable quadratic expression. So make sure you review how to do that. Essentially, one way, if you're most comfortable with factoring trinomials, you have u squared plus 0u minus 64 equals 0, and then you use AC method. Or you can remember that this is a difference of square. I always call it difference of square, but it's difference of squares technically. So essentially, remember, if you have u squared minus 64, that's the quantity u squared minus the quantity 8 squared, and that factors into u plus 8, u minus 8. So before, what we would do in order to solve an equation like this was set this guy equal to 0, and then we say, oh, 0 product property tells me that u plus 8 can be 0 or u minus 8 can be 0. So I get two answers here, negative 8 or positive 8 for u. Okay, if you have that whole screen, go ahead and take a picture. There might be some cutoff at the bottom, so what I'm going to do in a second is erase this whole top portion right here, all the way down to the solution part. All right, so let me erase the top portion. So I'll emphasize the difference of square method here. And that's going to move, isn't it? Oh, there we go. All right, so if you need to take a picture of this part, go ahead and take a picture as well. Now, that was just one way we've learned to solve a type of equation like this, okay? I'm going to start the formal number one now, so I'm going to erase all of this. And I just want you to recall when we solved this equation using difference of squares, factoring essentially, we got two solutions. We're going to see how that comes to play in the zero product property. So you have u squared, this is number one formal. U squared equals 64. So you see how the u squared is completely isolated? Like you don't have u squared plus u or u squared minus u. There's no u term over here anymore, okay? So what we're going to do is undo the square with a square root. So we're going to take the square root of both sides. When you do this, leave yourself a little space right here. Okay? The reason is, if we take the square root the way that this looks right now, we get u equals 8. But remember, from the factoring form of this, we got a plus and a minus 8. So whenever you take the square root of both sides of your equation, you need to put a plus minus, okay, on the non-variable part. So there should be a plus minus here. Both u equals 8 and u equals -8 are real numbers. So we have two solutions. You could have just left it like this line right here if you're thinking about a test or something where you'd be writing out. But if Alex asks you to write your answers in comma form, you're going to want u equals -8 and then comma 8. Okay, so let me go ahead and save this picture and then take a little pause here. All right, so we've gone over number 1. We saw how the square root property works. Let me go ahead and write that in by name. So square root property is used here, and it just means you isolate your squared term and then you take the square root of both sides. All right, let me clear everything here. And then let's go into number 2. So we're solving the quantity x plus 9 squared minus 63 equals 0, where x is a real number. Simplify your answer as much as possible. So we start x plus 9, the quantity squared, minus 63 equals 0. I'm going to want to use square root property here because I have this factor term here that I can isolate because it's squared. Okay, so let me start by adding 63 to both sides. And then I have x plus 9, the quantity squared, equals 63. Now from here, notice the squared term is isolated, which is exactly what you want. When your squared term is isolated, use square root property. Emphasis though, you only want to have squared terms and essentially other terms that have x's in them. You don't want to have those there. So you don't want to have a plus x or something here because that'll mess everything up. Just want to have your isolated squared term and some number over here. Okay, so now what we're going to do, we're going to take the square root of both sides. Leave yourself a little space. And then you're going to put a plus minus. Okay. Now a rule of thumb that happens on the left side here, if you have a squared term like this, when you take the square root, you're just going to get the factor back out. Okay. So once that happens, you can drop the parentheses. X plus 9 equals plus minus square root 63. If you need to take a picture of that, go ahead and do it because I'm going to erase the top part and move it all up. Actually, I'll move the whole thing up. Okay, that's not gonna work. Here we go. Not quite sure how it looks. All right, now here, I want you to remember what the goal is. The goal is to find values of x that are real numbers, and x is right here. So what that tells me is my next step is to subtract 9. And then another rule of thumb for you. So we have x equals whatever value I add or subtract last here to my radical, I just put it right in the front. Otherwise, it looks confusing if I put it in the back. You could. So like that, instead of writing x equals plus minus square root 63 minus 9, because then you start getting confused, like, oh, do I expand this over? Does the plus minus go to both terms and all this other kind of stuff? So I suggest writing the constant out in front and then put the plus minus radical. Take a picture if you need it. I am going to erase the majority of this now. Okay, so I'm going to erase all this stuff up here. All the way down to our isolated x, so that we can see we're not completely finished yet. Okay, so let's put this part in blue after we make the whole thing in black to emphasize the changes. Okay, so now we must simplify the radical if possible. Okay, so that's the one where you have to use the activity we did last week where you're simplifying radicals. I know that square root 63, actually, let's not even do the square root part. Let's just look at 63. Prime factor it. I get 9 and 7. And then 9 is 3 and 3. So 63 is 3 squared times 7. So square root 63 is the square root of 3 squared times 7. Remember, you have a pair of 3's underneath a square root, so 1 3 will come out, and then you're left with root 7. Okay. Try moving this up again. No. Okay, that's, there we go. Okay, just so I can keep it on the same page. So from here, what we get is x is equal to -9. And then you're going to have this plus minus 3 root 7. And that's as simple as the answer can get. Now, if I'm getting my classes mixed up. If Alex tells you to separate your solutions with commas, you'll put x equals -9 plus 3 square root 7. comma, -9 minus 3 square root 7. So the plus minus is where you're splitting your two solutions.
Would you add up the -9, Professor, and the -3, or you just kind of leave it there?
What?
Would you add the -9, -3?
No, because they're not like terms. So remember, go back and review that last video. Essentially, whenever your radicals aren't the same, so like see how we have a radical 7?
Yeah.
It's kind of like saying -9 minus 3x.
Oh, okay, they're not the same.
We
Got it.
wouldn't have those, right?
Yeah, it belongs to the square root of 7, the 3, like it's one term, right? The -3 square root of 7.
Yeah.
Okay.
Perfect. Oops, now I'm erasing all kind of things.
Mm.
Yeah, that's perfect.
Right.
C square root.
Oh,
Okay. Any other questions, comments, concerns about this one before I move to number 3?
on how you use that 3 squared times 7 in the middle of the problem, how you have square root of 63 equals square root of 3 squared times 7. You said, I thought you said isn't there an imaginary 2 on the outside of that square root, or did you say 3?
No. Prime factor first.
Okay.
When you prime factor 63, you get 2 3s and 1 7.
Yeah.
Remember, a square root undoes a square.
Okay.
So since we have a square root 3 squared here, 1 3 comes out.
Where do you put it on the outside?
Yes.
Okay.
And then you still have a radical 7 left over.
Okay. Got it. Okay.
All right, so far so good. Anything else? All right, so let me go ahead and take a picture of that. Go ahead and take a picture if you haven't done so yet. And then I'm gonna move on to number 3. I think this is actually a really good good length for this particular assignment because 5 problems in about an hour is pretty good. Let's clear this out and then scroll on down. Okay, next is completing the square, which is a little bit of a thing. So let me see. I'm actually going to write this one down and then do it on the whiteboard so that I have a little bit more room. X squared plus 16x plus 51 equals 0. Okay, so let's go ahead and read over the prompt before we head over there. So solve the quadratic equation by completing the square. Crapola, no. There we go. Okay, and then you have your quadratic equation right here. Okay, first choose the appropriate form here and fill in the blanks the correct numbers. Then solve the equation. If there's more than one solution, separate them with commas. Okay, so let me go ahead and do a new share with you, the whiteboard. Okay, so we have number 3, chapter 7, homework alternate. This is x squared plus 16x plus 51 equals 0 by completing the square. I'm often going to refer to completing the square with CTS. So I'll try to write the steps out in words on the side so that you'll understand what I'm doing throughout this process. Okay, so first thing, what we're going to do, we're going to subtract the c value over to the other side so that we just have x squared and x terms only on the left side. So let me put this in words. Get x squared. And let me be more specific. Get ax squared plus bx alone on one side. In this case, left-hand side's the best. By subtracting c from both sides. Okay, so we have x squared plus 16x plus 51 equals 0. And we're going to subtract 51 from both sides.
And that's C, right?
C.
Got it.
So now notice that I'm going to leave space where C used to be. So I have x squared plus 16x space and then equals negative 51 over here. So this is where it starts to get a little bit strange. Okay, so I think I should do this in another color. Let's do green. So what I'm going to do, you see my b value here is 16. I'm going to take b, divide it by 2a, and then I'm going to square it. And whatever that comes out to, I'm going to put right here. So let me actually do a few more extra steps here. I'm going to put a plus here and a marking underneath, and a plus here and a marking underneath. And then I'm going to put what goes here. Okay. So find b over 2a, then find b over 2a squared. You're going to need both of those values later.
Here.
And then put b over 2a squared in blank green spaces. Okay, so let's do that right here. B is equal to 16, A is equal to 1. We're going to see that for our process, we always will want to factor down so that we have x squared as our leading term, not like some coefficient in front, but just wait on that part. Okay, so for b over 2a, that's 16 over 2 times 1, which is 8. So b over 2a squared is 8 squared, which is 64. So I'm going to put that 64 on both the left-hand side and the right-hand side because I don't want to change the value of my equation. Like if I add something on the left but I don't add it to the right, I no longer have an equation. Okay. All right, stick with me on this. Gets a little more strange. Okay. All right, now what I want you to do, if you can, just cover up with your hand this right hand side of the equation. You should see a factorable quadratic. Okay, so let's put this step in another color. Step 3, factor the perfect square trinomial on the left side. So here we have x squared plus 16x plus 64. That's the perfect square trinomial on the left-hand side. Now, perfect square trinomial, let me know if you still have some trouble with that. Definitely read about it. I haven't gone over it in horrible detail yet. But essentially, a way to check that you have a perfect square trinomial, you see that there's a perfect square in the front, x, the quantity squared. And in the back, that's a perfect square, 8, the quantity square. You're going to check in the middle. There's a plus here. There's a plus here. What is 2 times this value times this value? In the middle, we would get 16x. And then expanding the ends again, we actually do have a perfect square trinomial here. So read about that and ask me questions if you have them. I'll go over that in more detail if you need it.
Isn't that like the X thing or not?
You can, just
But
different.
that's not what you were saying. Yeah, yeah.
Right.
Okay. Thank you.
So basically what you can use for this, you can use the AC method, which is honestly what I would suggest. Since we've been doing the whole remote thing and everything's been happening pretty fast, I would kind of prefer that you do use the AC method if you're not comfortable remembering the different types of special factors. So for this one, if you were to use the AC method, we have A is 1, B is 16, C is 64. We're looking for numbers that multiply to 64 and add to 16. So that's 8 and 8. And remember, we can skip grouping as long as the A value here is equal to 1. We would get x plus 8 times x plus 8, which is x plus 8 squared. So the left-hand side over here becomes x plus 8 squared. And then you still have on the other side the equals negative 51 plus 64. And we'll go ahead and find that value so that we can erase that. So this part here, when you add it up, is actually 13. Okay, now from here, before I continue, I just want you to note that you have an equation that you can solve using square root property. So that's going to be our 4th step. Do I have any questions, comments, concerns up to this point? Okay. So let me actually do this. All right, guys, so we left off with our completing the square. We have our factored perfect square trinomial on the left-hand side, and we have a positive 13 on the right-hand side. Our 4th step is going to be to use the square root property. To solve for x. Okay. So now what we're going to do, we're going to say, okay, I have x plus 8, the quantity squared, That equals positive 13. Leave yourself some space. And then when you take the square root of both sides, you get a plus minus in front of the number part, the square root 13. And then the square root cancels out the square on the left-hand side. So we have x plus 8 equals plus or minus. Please mute. Square root 13. And then final thing, remember you're trying to solve for x. So kind of like, I guess, step 4B, sort of, you can call it step 5 if you want, is completely solve for x. So in this case, I want to subtract 8 from both sides. Remember that tip that I gave you guys? You want to put whatever number you subtracted in the front so that the plus minus doesn't confuse you. Okay, so let me go ahead and save a picture of that. Also save a picture if you need it. What I'm going to do next is go back to the screen we were on so that you know how you're supposed to fill the boxes in. Any questions, comments, concerns so far? You can chime in.
Hold on, let me just get a picture. Thank you.
Okay.
Yeah.
All right. Let me go back here. Come on. Okay, there we go. So essentially the portion for this first form up here that you have, that's when you had the x plus 8, the quantity squared, equaling 13. Okay, so what you should have been filling in here, put 8, and then here put your 13. Just a rule of thumb, if you had x squared minus 16x plus 51 equals 0, your steps would essentially be the same for the most part, except since you have a negative here, you would have a negative for your perfect square trinomial. Okay, so if you have a negative here, you're going to use this particular form. If you have a positive here, you're going to use this form. Okay. And then finally, your solution, you're going to need to separate it with commas. So you're going to have x equals negative 8 plus square root 13, and then comma negative 8 minus square root 13. Any questions, comments, concerns so far? All right, so I was just happily going into number 4 and didn't realize that I had the recording paused still, so oops. Number 4 from the chapter 7 homework alternate, you have this quadratic equation given to you and you're looking for complex solutions. The complex solutions will include i's in them. We'll see that in a moment. So we'll need quadratic formula. Whenever you see complex solution, that's a good way to get a hint that you're going to need quadratic formula. Quadratic formula states the solutions to ax squared plus bx plus c equals 0 are given as this formula here. So first thing we want to do, identify a, b, and c. We see that a is equal to 2 from up here. B is equal to 3. and c is equal to -6. Step 2 is to plug in to the quadratic formula and solve for x. So we have x equals -b plus minus square root b squared minus 4 times a times c divided by 2 times a. Remember, this part here on the right is simplifying an expression. So we're going to start with the radical, simplifying under it first. Let me mark what we're simplifying in each step with blue. Why not? So the -3 won't change, plus minus doesn't change, square root doesn't change, and the 2 times 2 on the bottom doesn't change. In blue here, we're going to do the exponents first. 9 minus 4 times 2 times -6. Next step, keep your -3 plus minus, and then keep your 2 times 2 on the bottom. We're going to go ahead and multiply -4, 2, and -6. That gives us 48. So we're going to get underneath the radical 9 plus 48. Okay, so then now we have -3 plus minus 2 times 2 on the bottom, and then 9 plus 48. That's going to give us 57. And we still have our square root there. Let me double check one. Oh, all right. I think I'm going to scratch this whole part because I just, I rewrote my problem, right? I did. Okay, let me do this. Let me pause. Alrighty, so I made a little typo error when I went from the note guide to the whiteboard. There should be a +6 for your quadratic. So this is essentially my restart. Let me go ahead and write that up top. And I think I am going to end on number 4 so that we can get to Josh's part. I'll be able to cover number 5 tomorrow in tomorrow's video. Okay, so this should have been a +6. I put a minus above. So none of this has changed. Your quadratic formula is still going to be the same right here. You're going to start off the same way, identify your A, B, and C. My A is 2, my B is 3, my C is 6 though, not -6. And then I'm going to plug into the quadratic formula and solve. So I have -b plus minus square root b squared minus 4ac, all divided by 2 times a. So -3 plus minus, we're going to keep our 2 times 2 on the bottom as well, just to follow order of operations. The radical plays a parenthesis role in this case since there's stuff happening underneath it that can be simplified. So we're going to start with parentheses, exponents, blah, blah, blah. So exponents first. Okay. And then we are going to bring down the -3 plus minus. We have our square root. So have our 2 times 2 on the bottom. We have 9 minus 48. And then in the next step, -3 plus minus, we have square root, 2 times 2. 9 minus 48 is going to be -39. And that's how we know we're going to get complex solutions. Negative in radicand tells us we have complex solutions. Okay. Let me save that. Do I have any questions, comments, concerns so far? Okay. So take a picture if you need it. I'm going to clear this portion. And then I'm gonna move this portion over. Okay. And then I'm just gonna carry this on over here. So x equals, we have -3 plus minus. Essentially for this part, your square root -39, that's the square root of -1 times 39. And divide. And at this point, we can go ahead and multiply the 2 times 2 on the bottom. We could have done it a little bit earlier. If you know where, you can. If you don't know where, don't. Okay, so x equals, we have -3 plus minus, and then this is all over 4. So now what happens to this? You can split the square root -1 from the square root 39. They're still multiplied together. And then in your next step, things that don't change, your square root -1 becomes I. Okay, so I by definition is equal to the square root of -1. You still have a square root 39 next door. Now, I believe this wants you to write it in standard form. You can try it in your homework. If it lets you type it in that way, great. But essentially standard form for a complex number is separating the A and the BI part, like the real and the imaginary part. So x would be equal to -3 over 4 from here, plus minus square root 39 over 4 I. Okay, so that part's from here. So those would be your two solutions. You can check square root 39 is not reducible. So that covers number 4. So I'll start tomorrow's video with number 5. I'll go into a little bit more detail about the discriminant, which is here, the b squared minus 4ac. And we'll talk about how we know if we have real solutions or complex ones in more detail. All right, let me save that picture and then let me pause the video and ask questions.